So our next lesson is 10.2 products and quotients of functions. So the last one we did addition and subtraction, and this one we're going to do multiplication and division. Now, on this front page, it goes through a little summary of what we did like last time. F times G, F plus G, F times G, or F divided by G. If you look here, if you see F closed dot G of X, you would rewrite it as F of X times G of X. And then we would just multiply them. So 2 lines multiplied, x plus 3, 2x minus 1, would get us 2x squared plus 5x minus 3. And if I did f of x times g of x or g of x times f of x, I would get the same thing. Division different. So if I have f divided by g of x like this, I need to rewrite it as f of x divided by g of x. The reason why quotient is a little bit different is you end up with variables in your denominator, and the moment you end up with variables in your denominator, you end up with non-permissible values or asymptotes or points of discontinuity. So that's why this lesson gets taught after rationals, because we need that information. Okay, the domain of product or quotient of functions is the domain common to the original functions. The domain of quotient functions may have a restriction to the divisor, so the bottom, because it cannot equal 0. That is, for h of x equals f of x divided by g of x, the values of x are such that g of x cannot equal 0. Now, so with the domain of adding, subtracting, and multiplying, where the two graphs both exist is the domain. For dividing, for quotient, the domain is where they both exist, but also where the x values can't be, because they would make the denominator equal to 0. So quotient, you have to do that extra little step to get the domain. You have to find the x values that don't exist. If you can hear my daughter screaming, she is just talking, but that is how loud she talks. She talks that loud all the time. It's awesome. Still in my basement suite, still waiting for my house to be built. So soon, hopefully, they're thinking June now. It was supposed to be March, so here's hoping. All right. Example 1. Determine h of x equals f of x times g of x and k of x equals f of x divided by g of x for each pair of functions and their domain and range. So h of x is going to be f of x times g of x. So we're going to do 2x minus 1 times 2x minus 3. And then we have to FOIL them. So we're going to get 2x times 2x, which is 4x squared. 2x times negative 3, which is negative 6x. Negative 1 times 2x, which is negative 2x. Negative 1 times negative 3, which is positive 3. And then we're going to combine like terms. So we get 4x squared minus 8x plus 3. It's a quadratic, so its domain is XER. I also knew that its domain was XER because f of x is a line, which is XER. G of x is a line, which is XER. So their combined domains, where they both exist, would be XER. So that's set notation. Negative infinity to positive infinity is interval notation. And so we have those. So what I'm going to suggest is we can check it with our calculator. So we're going to type in 4x squared minus 8x plus 3, and we're going to press graph. Okay? And I'm going to go zoom 6 because I want to have my standard negative 10, 10 window. So my domain is for sure XER. To get my range, I have to go to my calculator. So I have to type this into my y equals. So I go to my range and I see I have a minimum. So I do second, trace, number 3, left bound, enter, right bound, enter, and then enter. And I get 1 and negative 1. So this graph's lowest point is at y equals negative 1. So my range is going to be y such that y is greater than or equal to negative 1, because the whole graph is greater than that, YER. So I can literally just plug the equation I found into my calculator and get its domain and range that way. And I'm from negative 1, square bracket, sorry, because it's equal to it. Negative 1 to infinity is my interval notation. Okay. K of x is f of x divided by g of x. So f of x is 2x minus 1 divided by g of x, which is 2x minus 3. My domain of the combined two, I can't cross off. Please don't cross the 2x and the 2x off. They're attached to the minus 1 and to the minus 3. So the only way they're canceling off is if 2x minus 1 is in the bottom or 2x minus 3 is in the top. The domain of the combined two functions is XER. However, it's a division. So I also have to check my non-permissible values. So this one here. So I have 2x minus 3 cannot equal 0. So 2x cannot equal 3. Divide by 2. X cannot equal 3 over 2 is my vertical asymptote. What happens when I go to state? Oops. What happens when I go to state my asymptotes for domain? Well, it's just going to be that it can't equal that, remember? So my vertical asymptote, I'm being lazy, please don't ever write BA. I just don't have a lot of room and I write really bad on here, is x equals 3 over 2. It's not a point of discontinuity because it didn't cancel off, right? So we're using that rationals and radical information from the last two units for this other functions unit. So the domain is going to be x such that x cannot equal 3 over 2 because it equals everything else, XER. Our range is going to be based off of our horizontal asymptote. So we need to use those rules from before. Look, they're the same degree. If they're the same degree, we take a fraction of the leading coefficients. So it's going to be y equals 2 over 2, which is actually just y equals 1. So I'm going to go y such that y cannot equal 1, YER. So we are using previous units material. Okay. B, you can try on your own. Pause it. So h of x is equal to f of x times g of x. It says it in the question. So we're going to do 3x times 2x minus 3. So I'm going to distribute, and I'm going to get 3x times 2x, which is 6x squared, 3x times negative 3, which is negative 9x. My domain is XER because my two original functions are lines and they're XER, or the fact that you can type it into your y equals. So I'm going to type into my y equals on my calculator, 6x squared minus 9x. I know it's a quadratic, so it has the domain of XER, or an interval notation, negative infinity to positive infinity. It's concave up parabola, so I need to find the minimum for my range. So second trace, number 3, which is minimum. Left bound, enter. Right bound, enter. And then enter. My lowest y value is negative 3.375. So because it's a minimum, it's y such that y is greater than or equal to negative 3.375 YER. Or an interval notation, square bracket, that does not look like one, negative 3.375, comma, infinity, round bracket. It's always round on infinity. K of x is division. Oh my goodness. So I'm going to have f of x divided by g of x, because up here it tells me that's what k of x is. So it's going to be 3x divided by 2x minus 3. Now nothing cancels off, that's as good as it gets, but I have to get my domain and range, and I can use last unit. So my vertical asymptote is going to be at 3 over 2 again, because look, 2x minus 3 in the previous question, 2x minus 3 still in my denominator, right? So I have a vertical asymptote at x equals 3 over 2. So this is why it's so important that we do well in our previous units, because we use them again, right? And then our horizontal asymptote uses the rule. Oh my goodness, it literally, my writing is so bad on this thing. My horizontal asymptote, they're both degree 1, so I take leading coefficient fraction, so it's 3 over 2. So I'm going to get y equals 3 over 2. So they're actually both 3 over 2. So my domain is x such that x cannot equal 3 over 2, XER. And my range is y such that y cannot equal 3 over 2, YER. Last one you can try as well. So h of x is f of x times g of x. Now remember, with product, it's where they both exist. I have a radical. Whenever I have a radical, I have a restricted domain. So under that radical, I have 4 minus x, and it has to be greater than or equal to 0. So then I'm going to subtract 4. Negative x is greater than or equal to negative 4. Divide by negative 1. X, my inequality sign flips when I divide by negative, is less than or equal to 4. So for the radical equation, 4 minus x, I have a domain of x is less than or equal to 4. For my linear, I have XER, but the domain is where they both exist. So it's going to be x such that, ooh, that's not a good x. X such that, I just need to scan in. X is less than or equal to 4. XER. Now you could expand this. You could go 5x, this equation, if you really wanted to. You could distribute the radical in. So you could go 5x square root 4 minus x, so just times, minus 1 times square root 4 minus x. Ooh, wow. Okay. So I can type that into my calculator, either the first version or the second one. So I'm going to look for my range and to check my domain. So I'm going to go 5x square root 4 minus x over minus 1 square root 4 minus x graph. So it for sure looks like it's less than or equal to 4, which is perfect. I have to make my y max bigger to see the maximum. So I'm going to go to, say, 30. So I go to window, I go to y max, and I change it to 30. Now I can see the highest it goes. So I'm going to go second, trace maximum. Left bound of the maximum, enter. Right bound of the maximum, enter. And I get it at 4.26. So my range is going to be less than that. Y such that y is less than or equal to 14.26. So you're going to be using your calculator for this, YER, to find your range by plugging that equation in. Now k of x is division. So I have f of x, which is square root 4 minus x. And then on the bottom I have 5x minus 1. I know I have a vertical asymptote. So I go 5x minus 1 equals 0. 5x equals 1. X equals 1/5. So I know I have a vertical asymptote there. But this one has a radical, so I'm going to type it into my calculator. Now remember, you can go alpha y equals enter to get the fraction. Or you have to type, if you're going to type it in without the fraction, you have to make sure that you go y equals this in brackets divided by this in brackets so that your calculator knows it's a fraction. Normally I would use my calculator on my smartboard, but I am not there. Okay. So basically my graph still does not exist at 1/5 for x, but it also still has to be greater than or equal to 4 because of the, or sorry, less than or equal to 4 because of the radical. So my domain is going to be x such that x is less than or equal to 4, comma, x cannot equal 1/5 XER. And my range is just not equal to 0. And I can just find that from my calculator. Man, I'm really good at that line stuff. Okay. Now, we can do what we did before, where we can find specific points. So we have f times, so it says use the graphs of f of x times g of x to evaluate the following. It gives you a graph, and it wants f times g of -1. So the first thing I'm going to do is rewrite that. F of -1 times g of -1. So I just need to get those y values off the graph like we did in the previous lesson. That's why the previous lesson was so much longer to explain this. So f of -1 is at -4 times g of -1, which is at 5. So it's -20. And that is the answer. The answer is -20. But what I wanted to reiterate to you is I'm actually finding a coordinate on the f times g of x graph. So on the f times g of x graph, I have a coordinate at -1 and -20. That's really what I'm finding. But the answer to this question is -20. Okay? B is f of 1 divided by g of 1. So f of 1 is f of 1 is up here, 2, divided by g of 1, which is -3. And that's the answer. So the answer to this is -2/3. What I was trying to tell you is, on the graph of f of x divided by g of x, I found a coordinate at 1 and -2/3. So that's really what you're finding. Every single time you're plugging in an x value, you're finding a coordinate on that graph. So now I have g divided by f of 0. So I have g of 0 divided by f of 0. So what am I indirectly finding? I'm finding the y value on the graph of g of x divided by f of x at 0. So at 0, f is -1. I meant to do g first, sorry. F is -1 and g is 0. 0 divided by -1 is 0. So the answer to this one is actually 0. However, oh my goodness, I'm really good at that. However, if I did f of 0 divided by g of 0 instead, say they had asked me that, now it would be -1/0, which is actually, you can't divide by 0. It would be undefined. On the graph of g of 0, or f of 0 divided by g of 0, at 0, I would have a vertical asymptote. That's what it means. So whenever I get this, where it's dividing by 0 and it gets me undefined, on the graph of f divided by g, I would actually have a vertical asymptote at -1. Or at 0, sorry. D is g of 3 times f of 3. And some people may be, sorry, going back to C. Some people may say, like, where the heck did this come from? This is just a caveat. It's not actually part of C. I was just saying that if f of 0 divided by g of 0 was something you did, you'd get undefined. So you'd get an asymptote on that graph. It has nothing to do with C, though. Okay, D is g of 3 times f of 3. G of 3 is -4 times f of 3, which is 5. So it's -20. So what did I find again? I found a coordinate on the graph of g of x times f of x at 3 and -20. Last page. So here's where you sketch them. So they want me to sketch f of x times g of x. So remember when I did that on the previous lesson? What you had to do is you had to take the same x values and multiply them. They're y's. So I can't start it anywhere below -2 because -2 is where both graphs start. So I'm going to show it over here. So I'm going to do h of -2. which is just f of negative 2 times g of negative 2. F of negative 2 is the black graph, so it's at negative 5 times g of negative 2. Oh, I just did them backwards, didn't I? Darn it. F of negative 2 is the black graph. F of negative 2 is 4. Negative 4. Times g of negative 2, which is the gray graph, is negative 5. Which is negative 20. Oh my goodness, put my hand down. So I got a new coordinate. It's at negative 2 and negative 20, which is great. However, I don't have negative 20 on this graph, so I won't be able to sketch it. So now I'm going to try negative 1. H of negative 1 equals f of negative 1 times g of negative 1. F of negative 1 is negative 4, g of negative 1 is negative 3. So I get negative 4 times negative 3, which is negative 12, which is a great point again, negative 1 and negative 12. However, I won't be able to sketch it because it's off the graph. So I'm going to do h of 0, which equals, I should do a different color so they don't blend together. H of 0 equals f of 0 times g of 0. F of 0 is still negative 4, g of 0 is negative 1. Oh, this is positive 12, positive 20. How am I getting negatives? My goodness. Sorry, it's a positive 12 and a positive 20. Positive times a positive, or negative times a negative is a positive, Crystal. Okay. So I'm going to get negative 4, times negative 1, which is positive 4. So now I have a coordinate at 0 and 4. You guys are probably freaking out before being like, they're positives. See, this is when in class you're like, I see about 80 hands raise up, and I'm like, okay, what did I do wrong? And you're like, it's positive. And I'm like, boom, yeah. But now I'm just talking to myself. Like a weirdo. That's what I'm doing. Okay. So let's do h of 1. H of 1 equals f of 1 times g of 1. F of 1 is negative 4. That doesn't change the whole time. G of 1 is 1. And now it's actually negative 4. So I have another coordinate at 1 and negative 4, which fits on my graph. And then I can keep going. Great. H of 2. F of 2 times g of 2. F of 2 is negative 4. G of 2 is 1, 2, 3. So now I'm negative 12. Now I have a coordinate at 2 and negative 12. And I could keep going, but that's probably enough points to plot. So I'm going to go along and I'm going to plot them. Okay, negative 2 and positive 20, I can't plot. Negative 1 and 12, I can't plot. 0 and 4, I can. Color. 2 and negative 12, I can't. 1 and negative 4, I can. And it's just a line, so I can actually just connect them. And there's your line. Pretend it's straight. All right. With division, we have f of x divided by g of x. Okay. The catch is the very first thing I always do is I look for where g of x equals 0. Because wherever g of x equals 0, I'm going to get a non-existent. So I'm going to get a vertical asymptote. So where g of x equals 0 is here, I immediately go to that first and I draw myself a vertical asymptote. Okay, then I work around it. So I always do that very first when it's division. Wherever g of x equals 0, I draw myself a vertical asymptote, then I work around it. So I'm going to find k of negative 1. No, I can do negative 2 actually, because it's on the graph. K of negative 2 equals f of negative 2 divided by g of negative 2. How my writing is something else. So f of negative 2, f is still the black graph, f of negative 2 is here, it's at negative 4, divided by g of negative 2 is negative 5. Which is 4/5, or if we want to plot it, it's 0.8. So I know I have a coordinate at negative 2 and 0.8. Okay, then I have k of negative 1. I'm going to do it in a different color. K of negative 1 is f of negative 1 divided by g of negative 1. F of negative 1 is negative 4. G of negative 1 is negative 3. It's negative 4 over negative 3, which is 1.3 repeating. I'm only turning it to a decimal so I can graph them. Or if it would be a decimal that doesn't work out evenly, I would leave it as a fraction. So it's at negative 1 4/3, but for the case of drawing, it's 1.3 repeating. Okay, I'm going to do k of 0. So I get f of 0 divided by g of 0. So f of 0 is at negative 4. G of 0 is at negative 1. So that one's at 4. So I have a coordinate at 0 and 4. And then I can do k of 1 equals f of 1 over g of 1. F of 1 is negative 4. G of 1 is 1. So it's negative 4. So I have a coordinate at 1 and negative 4. Then I can do k of 2, which is f of 2 divided by g of 2. F of 2 is negative 4. G of 2 is 3. So now I have negative 1.3 repeating. And then I could do 3 still. K of 3 equals f of 3. Oh, sorry, I didn't plot that one up here. The previous one is at 2 and negative 1.3 repeating. Go back to my gray. F of 3 divided by g of 3. F of 3 is negative 4. G of 3 is 5. Which is negative 0.8. 3, comma, negative 0.8. Okay. Plot all of those. Get rid of these. So I have the asymptote. That didn't change. Vertical asymptote, because that's where g is equal to 0. And now I get to plot all the rest of my points. It's red. Okay. So negative 2 and 0.8. Negative 1 and 1.3. So not going to be perfectly accurate because I'm using a stylus. 0 and 4. So what I actually have is a rational here, right? A rational graph. It looks like it has a horizontal asymptote possibly at 0. Let's see. Then I have 1 and -4, 2 and -1.3, 3 and -0.8. Yeah, I would guess that I have a horizontal asymptote here. There's my graph. What they could also do is they could give me the equations like we did before and do f times g of -3. So then I would go rewrite it, where they gave me f of x equals x squared plus 1, g of x equals -2x. So now I'm going to find f of -3 times g of -3. And off of a table, you could get the y values. Off of a graph, you could get the y values. Off an equation, you have to do them off to the side and find their y values. So I'm going to find f of -3 off to the side. I'm going to get -3 in brackets squared plus 1. -3 squared is 9 plus 1, which is 10. So f of -3 equals 10 times, then I have to do g of -3 off to the side. G of -3 equals -2 times x, so -2 times 3, so it equals -6. So I'm going to get -60. And that's my answer. What did I indirectly find? On the graph of f times g of x, there's a coordinate at -3 and -60. Okay, then I have f over g of 0, which I'm going to rewrite as f of 0 divided by g of 0. And then below I'm going to find f of 0. F of 0 equals x squared plus 1, so 0 squared plus 1. 0 squared is 0, plus 1 is 1. So f of 0 equals 1 over g of 0. G of 0 is -2 times 0, which is -2. So my answer is -1/2. And then the last thing they could do is they could give you a function, h of x equals f of x times g of x, and f of x equals 2x plus 5, and they want you to find g of x when they actually give you the answer. They give you h of x. So we did this at the end of the last one. So we just fill in. H of x is we're going to go h of x, oh my goodness, h of x equals f of x times g of x. I'm just going to rewrite it for myself. H of x is 10x squared plus 13x minus 30. 10x squared minus 13x plus 30. Just going to make sure I wrote that down right. 10x squared plus 13x. Nope, I did not write it. X squared plus 13x minus 30 equals f of x, which is 2x plus 5 times g of x. So the 2x plus 5 is being multiplied by the g of x. So if I want to get g of x by itself, I'm going to have to divide by it, the 2x plus 5. Wow, the birds are going wild outside. They're singing their little tune, all happy. Okay. Wish you could hear what I hear. I'm just talking about stuff and you can't hear any of it. All right. So currently we have g of x equals 10x squared plus 13x minus 30 over 2x plus 5. That's my g of x. but I actually have to factor 10x squared plus 13x plus 30 and see if possibly one of the factors is 2x plus 5 and we'll cancel. Okay, so up here I'm going to do it. So I'm going to go 10x squared plus 13x minus 30. All right. So what multiplies to give me 300 and adds to give me 13? Well, let's see. 10 and 30 would give me 20, so that doesn't work. What about 15? Nope. 25 and 12 is what it is. So we're going to do 10x squared plus 25 x minus 12x minus 30. Group the first two, group the back two, put a plus sign in between. I can take a 5 out, and then I'm left on an x, and I'm left with 2x plus 5. Back part I can take out a minus 6, and I'm left with 2x plus 5. So my two factors are 2x plus 5 and 5x minus 6. So on the top of this, sorry, I had to clear my throat. On the top of this, I have 2x plus 5. Oh, it didn't even work. It's awesome with this program is I can't pause, so you get to hear my clearing my throat. You're welcome. 2x plus 5, 5x minus 6 over 2x plus 5. And the 2x plus 5's cancel. And so g of x equals 5x minus 6. What's great about these is you can try them. You can check them. So you can do 5x minus 6, and you can times it by 2x plus 5, and you should get 10x squared plus 13x minus 30. So you can always check these. And then the last one, h of x equals 3x minus 1 over square root x plus 6. And it equals f of x, which is 3x minus 1 over g of x. Well, looky here. This one's even easier. If 3x minus 1 equals 3x minus 1, then we can say that x plus 6, square root x plus 6 must equal g of x. And that's it. That's all. Have a good day. Oh my goodness, I ended with that. Have a good day, guys.